Okay, so I'm going to work through the solutions for the crypto problems. Um, so in the first problem, you have the encoding matrix being 1, -1, 0, 1, 0, -1, -6, 2, 3. And what we need to do is first come up with the message matrix. So remember, in this problem, we are encoding the message cell consolidated. Okay, so when we create the message matrix, it has to have the same number of rows that are in the encoding matrix, the A matrix. So this has to have 3 rows. Now, what I did is I went into the table that's in your notes to be able to do the letter to number transformations. So S is 14. And then, sorry, not 14, 19. And then you go down the column. So the E is 5, L is 12, the next L is 12. Now there's a space here, so where the space is, we make a 0. The C is 3. The next O is, again, 15. N is 14. S is 19. The O again is 15. L is 12. I is 9. D 4. A 1. T 20. The E is 5, and again the D is 0. But we have another empty space here at the end because I need a number to fill out the matrix. Now, if you go into MATLAB and you multiply these two matrices, A times N, the resulting matrix that you're going to get there is 14, 7, -68, 12, 9, -63, 1, -4, -5, 3, 6, -39, 3, -16, 38, 1, 5, -22. All right, but we don't present the message as a matrix like that. We present it as just a list of numbers: 14, 12, 1, 3, 3. Oh, sorry, that's not correct. I have to go down the columns. 14, 7, -68, 12, 9, -63, 1, -4, -5, 3, 6, -39. I'm going to run out of room, so I'm going to continue up here. 3, -16, 38, 1, 5, -22. So the code recipient would receive this. They would already have our key, and they could invert that key with this message and get back the message that we sent. So that is problem number 1. Okay, so the second one we have here, we're given a different transition matrix. Our transition matrix, or the encoding key, it's 2 by 2 for this one. So it's 1, 2, 3, 5. Okay, the message that we're trying to encode is come home soon. Okay, so because this is 2 by 2, this thing's going to be only 2 columns, but it's going to be really, really narrow. Or, yeah, that'll work. So the C is 3, the O is 15, M is 13, the E is 5, and then we have a space, right? So the H is 8, the O is 15, the M is 13, the E is 5, and then we have another space. The S is 19, O is 15, the next O is 15, the N is 14. So this is my message matrix, AM. So if I take A times M, I'm going to get the coded matrix, which is going to give me 33, 84, 23, 64, 16, 40, 41, 110, 5, 15, 49, 132, 43, 115. Okay, so again, when you're giving the message, though, you write it as a list. 33, 23, sorry, that's not correct. Got to go down the columns. 33, 84, 23, 64, 16, 40, 41, 110, 5, 15, 49, 132, 43, 115. Okay, so that's problem 2. So in problem 3, we're given a big transition matrix. Our matrix is -2, -1, -1, 3, 3, 1, -1, 1, -1, 1, 1, -2, -1, 1, 2, -4. Okay, so remember, the only thing that the transition matrix has to have is it has to be square and it has to be invertible. Okay, so in this problem, the message is help is coming. So we create our message matrix. This one's going to have 4 rows because it's a 4x4 transition matrix. So the H gives me 8, E is 5, L is 12, P is 16, and then we have a space, so we put a 0. The I is 9, the S is 19, and then we have another space, so we put a 0. 3, 15, 13, 9, 4 for the N, 14 for the N, 7 for the G, and then we're going to leave 2 empty spaces at the end. So if I take A times M, I get my coded message matrix, which is -29, 25, 31, -59, 8, 28, 10, -29, 17, 34, 13, -38, -7, -7, -21, and 49. So remember, when we write this out as the list, we have to go down the columns, so it'll be -29, 25, 31, -59, 8, 28, 10, -29, 17, 34, 13, -38, -7, -7, -21, and 49. And the person having this series of numbers with this key should be able to decode that message. Okay, so in number 4, we're going to go the other way around. We're going to assume that someone has handed us an encoded message. So we have 19, 22, 17, 61, -48, 48, 77, -58, 58, 145, -141, 122, 62, -54, 49. And we have the transition matrix 4 to 1, -3, -3, -1, 3, 2, 1. So this is an invertible square matrix. Now the matrix tells us that because it's 3 by 3, I need a 3-row coded message here. So what I'm going to do is I'm going to go across and I'm going to bring this into, that's a negative 22. I'm going to bring this into the columns in this thing. So I'll have 19, negative 22, 17, 61, negative 48, 48, 77, negative 58, 58, 145, negative 141, 122, 62, negative 55, 49. Okay, so it fits nice and snug in a 3-row matrix. If I take the inverse of A times that matrix, I get back another 3-row matrix. So it'll be 2, 5, 1, 13, 0, 9, 19, 0, 1, 23, 19, 15, 13, 5, 0. And then I decode these letters. The 2 becomes a B, the 5 an E, the 1 an A, the 13 an M, 0 is a space. 9 is an I, 19 is an S, 0 is a space. 1 is an A, 23 is a W, 19 is an S, 15 is an O, the 13 is an M, the 5 is an E, and a space, and it says Beam is awesome and humble too. All right, so that's problem number 4. We got a good message out of that. And let's take a look at number 5. All right, in problem number 5, you're given the A matrix. The A matrix here is, oops, shoot. Okay, there we go. So that's a little better. The A matrix here is negative 1, negative 1, 0, negative 10, negative 6, negative 1, negative 8, negative 5, negative 1. Now, I'm not going to write out the whole list, but the D matrix here is got some really big numbers. Negative 177, negative 113, negative 21, negative 239, negative 156, negative 27, negative 242, negative 149, negative 28, negative 10, negative 6, negative 1, negative 310, negative 190, negative 33, negative 28, negative 22, negative 2, negative 253, negative 160, negative 26. Okay, so when we take the A inverse D to decode this, we end up with 7, 120, 19, 225, 0, 9, 19, 0, 1, 0, 4, 21, 12, 12, 0, 2, 15, 15, 11. And let's see, the 7 becomes a G, A, T, S, B, Y, space, I, S, space, A, space, B, O, R. Sorry, that's not correct. 4 is D. D, D. I can write a D. D, U, L, L. 4, 21, 12, 12. Space. 2 is B. 15 is O, O. 11, K. Gatsby is a dull book. So if when you talk to Miss Miller, you could tell her my opinions of The Great Gatsby, and you could share that with her and say that it made its way into a crypto problem in Mr. Beam's class. Even though it appears that in problem number 4, he may have some problem with spelling, but we'll get there. All right, so hope to see you soon. If you have questions, do them in the drop-in time or send me an email, and we'll go from there.